The universe has always presented us with surprises, but the arrival of 3I Atlas was unlike anything we had anticipated. This object came from interstellar space, and its behaviour immediately raised questions. Typically, objects from beyond our solar system follow erratic orbits, sometimes entering at steep angles, but 3I Atlas entered with a purpose, almost as if it were following a carefully plotted course. What we expected to be another comet-like object turned out to be something far more perplexing. When 3I Atlas was first spotted, it wasn't immediately clear what it was. Astronomers initially thought it might be another comet, but upon closer inspection, they realised something was very off. The object was shedding material in a way that no comet had ever done before. Instead of the usual single tail of gas and dust, 3I Atlas was creating multiple jets. What's even more unusual is that some of these jets were pointing directly at the Sun, against the natural direction of the solar wind. This behaviour was highly irregular, as comets typically only have one tail that points away from the Sun. The question quickly became, what is going on with 3I Atlas? As more observations were made, the situation grew even stranger. By November, astronomers captured images of the object, and what they saw was truly jaw-dropping. Jets of material stretching up to 3 million kilometres into space were visible, much larger than anything expected from a comet. This expansion wasn't just a few kilometres larger, it was thousands of times bigger than what had been observed earlier in the year. The scale of this was mind-boggling. Could this be a sign of something much more extraordinary happening with 3I Atlas than anyone had ever predicted? As scientists continued to monitor 3I Atlas, they began to observe something even more perplexing: the jets of material that were erupting from the object. Comets are known for releasing tails of dust and gas as they approach the Sun. This happens when the Sun's heat causes the ice in the comet to sublimate, creating a visible trail. But with 3I Atlas, the scale of its material loss was unlike anything anyone had seen before. Normally, comet tails extend to around 1 million kilometres at most. However, 3I Atlas was releasing jets that extended much farther, up to 3 million kilometres. That's 7 times the distance between Earth and the Moon. The size of the jets was astonishing. What made this even more baffling was the rate at which they were expanding. Back in July, the Hubble Space Telescope had captured a small glowing cloud around 3I Atlas. But by November, when new images were taken, these jets were 3,000 times bigger than what had been observed just months earlier. The speed at which this material was being ejected led to some serious questions. For jets to grow this rapidly, something beyond the typical cometary process must have been at play. Comets normally shed material steadily as they near the Sun, but the growth rate of 3I Atlas's jets seemed almost unnatural. What could be causing this rapid expansion? Another crucial factor was the behaviour of the jets themselves. As the Sun's solar wind pushes comets' tails away from the star, it generally controls the direction of the material. But with 3I Atlas, some of these jets were pointed directly at the Sun. This was completely counter to what was expected, and scientists were left grappling with the possibility that the object wasn't behaving like any comet they'd ever studied. Was this object a comet at all? Or was it something else entirely? An anomaly that defied the fundamental principles we had established. One of the most unsettling discoveries about 3I Atlas came when scientists started to calculate the material loss associated with this object. Normally, when comets release gas and dust, they lose mass in a way that can be tracked and measured. However, 3I Atlas was losing far more material than any comet of its size should be able to. In fact, the amount of material being lost was downright alarming. Avi Loeb, a prominent astronomer, calculated that 3I Atlas was shedding 50 billion tons of material every single month. This was a staggering number, especially when considering that the object itself weighed only around 33 billion tons. The math just didn't add up. How could something that only weighs 33 billion tons lose more than its own mass every month? This posed a real challenge for scientists. If 3I Atlas was losing so much material, could it even maintain its integrity over time? This question sparked an immediate investigation into the possibility that 3I Atlas was fragmenting into pieces. In the past, we've seen similar behaviour with objects like Shoemaker-Levy 9, a comet that was ripped apart by Jupiter's gravity in 1992. The fragmentation of the comet caused it to release far more material than anyone had anticipated. Could 3I Atlas be undergoing a similar process? If it was breaking apart, the increased surface area exposed to the sun could explain the accelerated loss of material. More surface area means more ice melts, which leads to more gas and dust being released into space. However, the possibility of fragmentation raised another question. If 3I Atlas was breaking apart, how were the jets staying intact? Normally, when a comet fragments, the pieces scatter and the jets dissipate. But with 3I Atlas, the jets remained powerful and focused, defying expectations. Scientists were left in a state of uncertainty. Could this object be breaking apart in ways we've never seen before? Or was there something more to 3I Atlas that we still didn't fully understand? As scientists continued to analyze 3I Atlas's jets and material loss, the possibility of fragmentation gained more attention. If the object was breaking apart, the increased surface area exposed to the sun would allow more material to sublimate at a faster rate, which could explain the massive jets. In the case of Shoemaker-Levy 9, the comet broke apart into multiple pieces, each fragment producing its own tail of dust and gas. The process was violent, but it made sense, until 3I Atlas showed a new kind of behavior. What was most puzzling about 3I Atlas's potential fragmentation was the fact that its jets were remaining intact for millions of kilometers. Normally, when a comet breaks into fragments, the jets begin to scatter. The object essentially becomes weaker as the fragments lose cohesion and spread out. But with 3I Atlas, the jets were perfectly focused, blasting material outward with precision and intensity that scientists hadn't seen before. Could the object be breaking apart without losing its structure? Or was it somehow creating these jets in a way that we had never imagined? The idea of anti-tails, which had been observed in other objects like Comet Holmes and Shoemaker-Levy 9, added another layer to the puzzle. Anti-tails occur when the jets of gas and dust point towards the sun, rather than away from it. While anti-tails are rare, they're not impossible. 3I Atlas seemed to be exhibiting this unusual behavior as well. The fact that the jets were able to remain so coherent, especially ones that pointed directly at the sun, suggested that whatever was driving the object's activity was extraordinarily powerful. This led astronomers to hypothesize that 3I Atlas might be experiencing a unique fragmentation process, something that could be pushing it beyond the known limits of cometary behavior. But until more data was collected, the mystery of its fragmentation and the strange direction of its jets remained unsolved. The discovery that 3I Atlas was traveling on a retrograde orbit added yet another layer of mystery to this already perplexing object. In our solar system, all the planets, including Earth, orbit the Sun in a counterclockwise direction when viewed from above the solar system's plane. Most objects that come from beyond the solar system also follow this counterclockwise motion. However, 3I Atlas was different. It was traveling clockwise, which is an orbit known as a retrograde orbit. This retrograde motion is incredibly rare, seen in only about 1 to 2% of objects in space. Retrograde orbits are typically associated with small moons that were captured by the gravitational pull of larger planets after the solar system had formed. So finding an object as large as 3I Atlas following such an orbit was a massive anomaly. But what made this even stranger was the fact that 3I Atlas's orbit was nearly perfectly aligned with the ecliptic plane of our solar system. Most interstellar objects arrive at steep angles, either above or below the ecliptic, which is the flat plane where most of the planets orbit. However, 3I Atlas was coming in almost directly along the plane, something astronomers said was virtually impossible to happen by chance. The likelihood of this happening randomly is extremely low, around 0.2%. This meant that 3I Atlas's path through the solar system was something extraordinary, even among the rarest of objects. Was this simply an extremely unlikely event? Or could there be something about the object's origin or purpose that we didn't understand yet? Was it truly an interstellar visitor, or was it following a path that was too precise to be accidental? This retrograde orbit, combined with the strange behavior of the object itself, made 3I Atlas even more intriguing. Its path suggested that there was far more to this object than a simple, chance encounter with our solar system. As the mystery deepened, it became increasingly clear that 3I Atlas might not be a simple celestial object at all. What other surprises were hidden within its strange, deliberate trajectory? As the mystery of 3I Atlas deepened, many scientists began drawing comparisons to another interstellar object, Oumuamua, which passed through our solar system in 2017. Much like 3I Atlas, Oumuamua was an unusual object that defied conventional explanations, leading to widespread debate about its true nature. Oumuamua's elongated shape and its strange acceleration as it left the solar system were baffling, prompting some researchers to even suggest that it could have been an artificial object, possibly a light sail, a solar-powered probe propelled by radiation pressure. But 3I Atlas was different in one crucial way: its size. While Oumuamua was estimated to be just a few hundred feet long, 3I Atlas was an enormous object, more than a mile wide and weighing billions of tons. This immense size only added to the mystery surrounding it. Was it a comet, a fragment of a shattered object, or something even more unusual? The difference in size and scale between these two interstellar visitors became the focal point of much speculation. While Oumuamua's unusual behaviour was intriguing, its small size and rapid exit from the solar system meant that it was difficult to study in detail. But with 3I Atlas, scientists had a much larger object to study, one that had entered our solar system in a much more controlled manner. The key difference between these two objects wasn't just their size, it was the duration of their behaviours. While Oumuamua passed through relatively quickly, 3I Atlas had been actively shedding material over a long period of time. Its massive jets and the possible fragmentation process made it far more complex to study, as scientists had the chance to observe its interactions with the Sun over several months. The sheer size of 3I Atlas, coupled with its strange orbit and behaviour, raised an important question. Could 3I Atlas be a more advanced version of Oumuamua, or is it something entirely different, something we've never seen before? Just when it seemed like the mystery of 3I Atlas couldn't get any stranger, astronomers detected a radio signal coming from the object. This wasn't just an ordinary burst of radiation, it was a patterned signal, something that seemed too deliberate to be natural. At first, the signal appeared to be a random burst of energy, but after further analysis, scientists realized it wasn't random at all. The signal was encoded in a way that suggested it had a purpose. The question quickly became, was this a communication from 3I Atlas itself, or was it something else entirely? This signal was unique because it followed a mathematical pattern, not the chaotic signals typically associated with celestial bodies. Some researchers believed the signal could be a form of cosmic coding, a signal intentionally sent by an advanced civilization or probe. It seemed to follow a prime number sequence, with the number 37 being particularly significant. The fact that it used prime numbers suggested that the signal was designed in a way that could be universally understood, possibly even a language meant for advanced civilizations to decipher. What made this signal particularly fascinating was its duration. The signal's frequency was consistent, with pulses occurring every 37 seconds. But it wasn't just the pattern that was odd. The signal itself was measured by the oscillation period of the hydrogen radiation line at 420 MHz. This frequency is crucial in radio astronomy, as it is the universal signature of hydrogen. The timing of the pulses matched up perfectly with the frequency of hydrogen, leading scientists to speculate that the signal was encoded with fundamental physical constants of the universe, including the fine structure constant, the electron-to-proton mass ratio, and other universal constants. As the research team continued to decode the signal, they discovered more clues about its purpose. Some scientists suggested that it could be a form of universal communication, a signal sent out to be decoded by any civilization capable of understanding it. Given that hydrogen is one of the most abundant elements in the universe, and its properties are universal, it was likely that this signal was designed to be understood by any intelligent species. But what were the next steps? If 3I Atlas was indeed sending a message, what did it mean? Was it trying to communicate something important to us, or was it simply a beacon from an advanced civilization passing through our solar system to observe us?